Hi everyone. Today we're just going to quickly look over transformations of other types of functions based on the parameters h and k. So here's today's focused learning target. Given other types of functions, so aside from quadratic functions, I'll be able to identify the effects of h and k by describing, graphing, or defining the function. So last time we focused on quadratic functions, but today we're going to take a look at some other types of functions too. So here are just graphs of different types of functions that we're going to take a look at today. So I'm going to list out different types of parent functions and their graphs, and also how it would look like if we add in the parameters h and k. So here's a linear function, something that you've probably seen in IM1. So the parent function is y equals x, and I know it's written a little bit strange compared to what we're used to saying, but if we add parameters h and k, it's y equals parentheses x minus h, and then the plus k. And then last time we looked at quadratic functions. So these are the parabolas with the parent function y equals x squared. And then if we add in the parameters h and k, it's just y equals x minus h quantity squared plus k. We're not really going to touch on this today, but I just wanted you guys to see it again. And this might be your first time seeing these types of functions, but that's okay. We have absolute value functions. Notice that it's a V shape instead of a parabola, so it makes like a sharp turn at the origin. And by the way, absolute values are like, even if it's a negative number, the absolute value of that is positive. So like the absolute value of -3 is just 3. And then we have cubic functions. So functions where the highest degree is 3, and the parent function is y equals x cubed, and it looks like this strange like squiggly mark. So how do the parameters h and k affect these types of functions? So, surprise, surprise, regardless of the function type, h and k have the same effects. So I made this little table down here so we can summarize our findings from the previous video. H talks about our horizontal translation, so left and right. And so when h is positive, we'd move to the right, and when h is negative, we'd move to the left. So h tells you your horizontal translation. K gives your vertical translation, so going up and down. So when k is positive, you go up, and when k is negative, you go down. So regardless of what type of function you're looking at, h and k still have the same effects. So for our first example, we're asked to describe and sketch y equals x minus 3 plus 2. And notice the parentheses right there. So first, let's think about what kind of function this is. Since the highest degree is 1, this is a linear function. So let's write out the form of a linear function. Again, this is a linear function because the highest degree is 1. Notice that we have an exact match, so the given function looks exactly like the general form. H is replaced by 3, so h equals positive 3, and k is replaced by 2, so k equals positive 2. So let's describe this transformation. Since it's a linear function, we know that we have a line, so a line that translates, and then think, in which direction are we translating this? Let's first focus on the vertical translation, so the k value. So we'd go 2 units upwards because k is positive 2. And what about the horizontal translation? Focusing on h, we'd move 3 units to the right because h is positive 3. Now we want to provide a sketch. So what would this look like on a graph? Again, it's a sketch, so it doesn't have to look super exact. So here's like the parent function graph, the line y equals x. And notice we have to move 2 units up and 3 units to the right. So what would this look like? We have this point at the origin, and we're going to translate it 2 units up and 3 units to the right. And we draw a line through it, and it would look something like this. I know it looks a little strange because you're probably not used to graphing lines looking at this form, but let me rewrite the original function. So the function we're given here is y equals, and then parentheses, x minus 3, close the parentheses, plus 2. But this is actually the same thing as just x minus 3 plus 2, removing the parentheses. That equals x minus 1. So this line is actually just y equals x minus 1. But I wrote it in this different format just because I wanted to show you guys that h and k still have the same effects, even if we're working with different kinds of functions. On Edpuzzle, please describe this function y equals x plus 5 plus 2. What would the translation look like? Next, let's look at this example. Describe and sketch y equals the absolute value of x plus 3 and then minus 4. So first off, what kind of function is this? So if we notice here, this is an absolute value function, so the general form would look something like this. And notice that although it looks similar, the given function doesn't exactly match the general form. So let's rewrite this. So I'm going to rewrite it so that it looks exactly like the general form. So I'd have y equals the absolute value of x minus negative 3, and then plus, we have negative 4. I'm rewriting it so that it matches the form. So now I can label h and k. So h equals negative 3. So think about what kind of translation that is. And then we know that k equals negative 4. So what kind of translation would that look like? So we have an absolute value function that's going to translate in a certain way. So I'm writing out the description here. An absolute value function that translates. And then, so first I'm going to look at the vertical movement. So since k equals negative 4, we know that we'll be moving 4 units downwards. Again, this is because k is negative, so we're moving down. And then what about the horizontal movement? Well, we're going 3 units to the left because h is -3. So we provided a description. Now let's provide a sketch. So it kind of got chopped off at the bottom, but don't worry about that. So I have my parent function here. And then we're going to be moving this or translating it. So 4 units downwards. So to the -4 point. And then 3 units to the left to the -3 point. So we're moving this point from the origin 4 units downwards, and then we're gonna move it 3 units to the left. And it would look something like this. Again, just a generic sketch will do. Please describe this function on Edpuzzle. Notice that we have an absolute value function. And so first, you want to label h and k to determine how the absolute value function would be translated. And let's take a look at one more type of function. So we're going to describe and sketch y equals x plus 2 quantity cubed. So since the highest degree is 3, we have a cubic function. So make sure you remember to focus on the degree first to understand what type of function we're working with. So we'll have x minus h quantity cubed plus k. And notice that our given function isn't an exact match. So we got to rewrite it. Y equals x minus -2 quantity cubed plus 0, because there's like that empty k spot. So h equals -2. And then k equals 0. So since k equals 0, we wouldn't move up or down. So there's no vertical movement, so we just have a cubic function that translates, and since h equals -2, it will just translate 2 units to the left, again because h is negative. So I provided a description. Now let's provide a sketch. So the parent function of a cubic function is that weird squiggly curve that looks like this. And we're just shifting it 2 units to the left. Slide to the left. And so it would look like this. Here's our sketch. And here's your final example on Edpuzzle. Describe y equals x minus 2 quantity cubed plus 4. So regardless of the type of function, h and k still have the same effects. H determines your horizontal translation, and k determines your vertical translation. Please remember to submit your notes on Canvas, and see you next time.